Good morning, everybody, again. Now, the next speaker is Mr. Salvador Giró. He is CEO of the company Infimon, and he will be an approach about the vision machine as a key technology for Industry 4.0, autonomous driving, connected car, and smart cities. Salvador, it's your turn. Thank you.
Thank you. Thank you, Luis Miguel, for the introduction, for the presentation. Thanks for coming to the Congress. Thanks to the organization for inviting us to talk about machine vision. Well, machine vision, computer vision, artificial vision, three different ways to talk about an important technology that is used in Industry 4.0, autonomous cars, and smart cities. Industry 4.0, where we are, where we go. We are not in the image in the right, and not in the image in the left. We are just in the middle today. What we are doing today is, or we are going today, is to work with collaborative robots. Persons and robots work together, and robots, what robots do? Robots is doing the most difficult jobs, the most tough jobs, the most heavy jobs, while us, persons, we are doing the most critical, specific, and smart jobs. Gracias. Thank you. OK, now it's better. If we look at this picture, you remember Charlie Evans that took this picture in 1930. If this picture has been taken in 2030, probably the picture will be like that, where collaborative robots will work together with persons. I hope that robots don't have vertigo, because if not, we have problems making things and making houses. Well, let's go directly to what is machine vision. What is artificial vision? Well, in fact, what we do is we take an image, we capture an image with a camera. From that camera, we extract some data, and from that data, we analyze the data, and what we do is take decisions. This is made in Industry 4.0, in autonomous cars, and in smart cities. We will see this later. OK, let's go directly to the Industry 4.0 and how it works, machine vision in that area. Well, what we have is several products in the conveyor belt. And what we do is when the product is arriving to the camera, one sensor says to the camera that take the image, and at the same time, the camera flashes a light, and then the image is taken by the camera, and it's processed. So the process could be done in a computer or in the same camera. Okay? Once it's processed, what we do is decide if the product is right or not. If it's right, then it follows. If it's not right, then we have an ejector or a robot that can take it out of the line. What we are doing here, we are talking machines to machines, M to M. We are sending the information. When we work with the smart cameras, in the smart cameras there is Ethernet connection, and we send the information directly to the central office in the factory, or the main office in Tokyo or Munich or Detroit. And all this information is going to a cloud in some time. And the information that we give is a lot, because these systems is working 24 hours a day, 7 days a week. So what we are doing here, we are doing M2M, machine to machine. We are doing IIoT, Industrial Internet of Things. We are doing cloud computing, and we are doing big data. All the data that we generate, it's processed. OK. Where machine vision is working today? According to the EMBA, the European Machine Vision Association, where we are working more is in the automobile industry. 30% of the machine vision products that today we are putting in our factories is in that area, the area where we are now here. But how it works, where we are? Well, we are in logistics, in traceability, in quality control, and also in production. Let's see how it works in logistics. When one truck enters in our factory, what we do is take the plate and also read the container, and at that moment, we can read if the container have hazardous products, and from this moment, we can have several cameras inside the factory and track these trucks through the factory. In any time, we can know exactly where we have the goods. Well, when the goods arrive to the door entrance, what we are doing, or what we will do in the next future? Well, there will be several robots guided by vision that could take all the goods and put them on the shelves in the warehouse. And then also they can take from the shelf and put them in the production line. This is not future. This exists. This company exists. But also Amazon is doing something like that, not so advanced, but close. What we more do in machine vision, we can read 1D, 2D, OCR, but not easy things. Things like that. So we are specialists to do very difficult things related with 1D and 2D and OCR. We can read also letters made by hand, and we can read this in 3D way. Let's see just an example. This is something that is working at high speed. We can do that at hundreds of images per second. And we can not just read, we can also at the same time, we can see if there is some defects on the labels, on the boxes, everywhere. What we can do more, what we are specialized. We are specialists in quality control. In small things, big things, any type of quality control that we can do is like something like see scratches, look for broken parts, see if something is bigger or smaller than what it has to be, or things so difficult like that. This is a tunnel, painter tunnel in the Ford factory, where we have 16 different cameras taking images of the full car, and what we do is we detect small defects. Small means something below a tenth of millimeter, okay? And after we are taking the defects, we put this in a map, and the people that work afterwards, they can polish the cars and they can clean the defects after that. Let's finish this, and well, this is how it works. Well, quality control. Till now, we have been working with the algorithms that it's working for a long time, but recently, we are incorporating in Industry 4.0 in machine vision the deep learning. Deep learning, neural networking, or more common is artificial intelligence. What we can do today, we have discovered just less than 1 year ago with that technology that what is impossible till now, today is possible. This is a big jump in our technology. Some years ago, no, not just some years ago, some months ago, we cannot do that. So we cannot look and see a defect in a textile like this, because it's very difficult to determine and to separate the defect from the rest. And today, with deep learning, we can do it. Deep learning is important in Industry 4.0, but also it's important in autonomous cars. We will see it. Something more, production. So the idea is we do vision. We can guide the robots to do something. Something like that. This is a beam picking system where the robot could see by their cameras in stereo the position of the objects and can drive the robot to the objects, and then they can pick up and put in another position. This is a technology that seems very easy. Any child could do it, but it's not so easy. The computers take time to do it, but this is resolved already. This is another application related with vision-guided robotics. This is one car looking at the gap and flash, so the difference between the door and the car, and what we are seeing is the gap and the flash. Okay, this is made, this application, here is static, but really is while you are building the car, the robot is following what they are doing. Okay, if you want to see these both applications, the last one that you have seen is already there in this in one booth, in our booth over there. Okay, let's talk now about autonomous cars. Autonomous cars. What is the main thing in the autonomous cars in terms of see what is happening? So autonomous cars have several sensors, different type of sensors. Sensors like radar, short and long range, ultrasounds, LiDAR, or cameras. As we are a specialist in cameras, let's talk about cameras. So how many cameras could be in a car? Attending to Tesla, you could see the car over there. They have 8 cameras on the car, 3 in front and 4 inside, 2 and 2, and 1 in rear. What is the advantage of the cameras? The cameras is very affordable today, really very cheap in terms of if you compare with LiDAR. And the advantage is that you can put as many cameras as you like. This is one. Second, the advantage of the cameras is that you could see color. You could see you could see on the street the lines on the street. You could see what is happening near to the road. But you can see more things than that. So you can see lights. You can see traffic lights. You can see the lights in front of you, the lights of the car in front of you, the brake lights, the turn lights, and also what we could see with cameras is what is happening around. So we can look at the persons around, look at the face and the gaze of these persons, and predict what they can do after that. So this is the main idea. The cameras could do everything to control the car. But what's the problem today? Well, the problem today is that the technology that we are using is not fast enough most of the time. So machine vision needs more power, in computer power, because we are using, as I told you here, we are using today artificial intelligence, and this takes a lot of power process. Well, we are going to some new solutions. These new solutions come from new technology. New technology is this. This is a camera. This is a camera with, this is the camera, okay? This is a camera with a sensor in front and ASIC in back, okay? This has been launched recently, just 1 week ago in the Embedded Vision Summit in Santa Clara, California. And this is a new technology on cameras. This is the second time that someone shows in an exhibition this camera. Well, the big idea here is the ASIC could do many things in terms of control of this control of the process of the image here. So what the camera could not do today, then we will do in the computer. But this is the future. So in the same camera, we could do everything, and we can connect this with the car. Okay, other cameras that we can use on these cars. So this is an infrared, low infrared camera. So these cameras could see at night with fog, slight fog, rain, slight rain, and snow. So if you look at the image, top image, this is the image of the visible camera. So you can see that they have shut down the lights. And with that camera, with the infrared camera, we can see perfectly the street. Well, this is the main idea. What was the problem in the past with the infrared cameras? Well, infrared cameras was extremely expensive, but this is gone. So today, infrared cameras is not as affordable of the rest of the cameras, but very close. More. More is, let's jump now to the smart cities. What you are seeing here, this is New York, from 5 a.m. to 12 a.m. in the morning. This is the traffic in New York taken by cabs, buses, ferries, trains, and this is what is happening, okay? So this is made with GPS. What we can do with cameras? What we can do with cameras is to put a camera in every one of the streets in the city and then follow, reading the plates, follow every one of the cars. That means that we have all the information of everyone in car in the city, and we can track it. And we have this information and put this information to predict what will happen in terms of traffic in the cities. It's not just traffic. It's also, with cameras, we can put them in train stations, for example, to see how many people is in the train station, if it's needed more trains or not. Inside of buses, how many people is inside the bus, if need more buses because the bus is crowded. Or still easy things like, for example, put some cameras, one camera in every one of the street lights, and just when you pass pass below the street lines, the camera look at you, see you, and then the light could be open. This is what we, machine vision, artificial vision, could do. So, as a conclusion, what we do, we take images. From these images, we extract the data. From this data, we analyze this data, and from this analysis, we can take the decisions. One important thing is that machine vision or artificial vision is one of the crucial technologies in the three areas. Autonomous cars, of course, Industry 4.0, and smart city. And this is all in my side. Thank you very much, and see you soon.